Thank
Next,
you.
we have Naga Murali Krishna Koneru, Hexaware Technologies Inclusive USA. Mr. Naga Murali Krishna Koneru is a technical architect at Hexaware Technologies Inclusive USA with 11 years plus years of experience in cloud architecture and DevOps. He specializes in designing scalable AWS infrastructures, implementing DevSecOps practices, and automating CI/CD pipelines using infrastructure as code. His expertise spans container orchestration, Kubernetes, cloud security tools, SAST, DAST, and optimized cloud migrations. A passionate technical leader, he focuses on building resilient systems while mentoring teams and driving cost efficient solutions through automation and best practices.
Hello, good morning, everyone. Good afternoon, good evening across the world. Thanks for giving this opportunity. Let me start my screen share and let's go through the presentation. Can you see my screen?
Yes, it's visible.
Yeah, thank you. Yeah, hi. So today's topic would be integration of security tools into CI/CD pipelines, DevSecOps with SAST, DAST, and SCA, a comprehensive approach to embedding security throughout the modern software delivery lifecycle. So in today's topic, so we'll be mainly focusing on uh, the best practices to include security tools within the CI/CD pipeline. So before we talk that, so let's do an introduction about what we're talking about. So in the modern software delivery, uh, the product should be firstly moved into the market, right? So we have an idea and it has to be implemented and should be released to the market at the earliest before someone picks that idea. So the automations of this delivery has become wide and crucial important to the organizations. So as part of that fast delivery, a lot of automations has been implemented, but at the same time, so we have to make sure that the software delivered is actually getting uh, properly scanned and analyzed with the the security which is very important. Okay, so software delivery is one of the thing, and implementing through various security protocols and security standards is very important. So let us focus on implementing those security practices onto the software delivery pipelines, which we call it as CI/CD pipeline. And this whole process we can call it as DevSecOps. So there are two aspects in the software implementation: DevOps and DevSecOps. DevOps is like you in the picture I'm just showing here, like it has different phases, like writing the code, like which developers will do, and then build, test, deploy, and monitor. These are all operations part. So they become as DevOps. So when it comes to DevSecOps, implementing the security across all the development and the operations, okay, each and every phase would be scanned and optimized with security. This is called DevSecOps. Let's go through various tools which we will be implementing in DevSecOps pipelines. Why DevSecOps? Why we have to implement this approach? In the earlier days, the product was already released into the production and it is used by the customers. Then the security teams used to do a pen test. Okay, like they do a standard protocol, some pen testing. So through which what you can do is it gets a result, and the report is given to the teams that these are all the flaws. So it's like after the production implementation, the product is released to the customer, and fixing that is going to be a challenge because already customer might be facing already some security threats, right? So in this case, the fixing of the bug or security flaw is one of the costliest thing, and second thing is already the customer is at the risk, right? It could be a data breach, or it could be password leaks, or it could be a security breach, or could be anything. So instead of doing the security scans and analysis at the end of the product delivery, so we move that implementation of the security to the earliest phases of the development. So this is what we call as shifts a security left. So DevSecOps finds and fixes the security related issues very early of the delivery life cycle. That means initially at the development phase itself. Then it enables a rapid secure releases. So when we do an automation, so it prevents bottlenecks, enabling the speed DevOps they want. So without sacrificing security. And so the early fix would be the earliest saving life, right? So this is what we call in the automation. The early you find out the bug, the cost would be less to fix that problem. Like cost means here the time and the number of software engineers that are working on that particular fix. Minimizes breach impact. Early continuous checks reduce the attack surface and speed up the remediation. And let's now talk about various types of security testings in the DevSecOps pipelines. So the first one would be static application security testing, which is called SAST. The name itself says that it's a static application testing, right? So the static means here the code. Okay, so we will be testing the security of the code, whatever has been written by the developers. And this SAST, when it will run, when the code is committed or merged, that means each and every time the developer pushes the code to a repository, like it could be a Bitbucket or a GitHub, GitLab, whenever the developer commits the code to code repository, this SAST scan runs. And what it tests, it catches the insecure code. As we mentioned, it does the static application testing. So here it focuses on the code, hard-coded secrets, unsafe logic, before it actually reaches to testing or deployment. So whenever we do a commit, so all these aspects, especially hard-coded secrets, unsafe logic, would be scanned in the SAST testing. Why it matters? Provides immediate feedback to developers, enabling quick fixes. So here developers can know what are the what this report is saying in the SAST, and they can quickly fix that. So basically it focuses on the developer work, and so the developers would be given a fast feedback. And what are the popular tools in SAST? So the popular tools are SonarQube, Checkmarks, SemGrep, Fortify, Sync. These are the major SaaS tools that are being used in the IT industry at this point. So I'm just showing a sample example of SAST scan. So as you mentioned in the previous slide, so SonarQube is one of the SAST scan tool. So if you see this report, okay, the left side you can see it has different types of vulnerabilities or findings, right? Bugs, vulnerability, code smells. Code smells is like bad practices in the code. Vulnerabilities and bug is like which can be fixed by the code change. And vulnerability is like within the code itself we found some issues with the code safety. Okay, and it will find out like the severity also, like blocker, critical, major, minor, and info. So on the right side, if you see the color patterns here, right? So the green says minor, and red arrow says major. Okay, critical. Okay, so it has different icons. So it explains each and every observation, and if you see it just can get a particular file of Java code, and it's actually identifying each and every issue what is found in that particular file. So the developers would be given this report so that they can go back immediately and fix that issue and rescan the code, and the remediations would be shown here. So basically we can set up a gate here. So we call it as a quality gate. Each and every layer, each and every scan can have a quality gate. So when the quality gate fails, okay, and the pipeline, that is the particular stage would fail, so that it doesn't move to the next step, right? So this is what a SAST scan looks like. So it's basically focuses on the code written by the developers. So this gives immediate feedback to the developers. And the next one is a dynamic application testing. So on contrary to SAST, this DAST, so dynamic application, so it actually tests on the execution of the application, not on the code. So when we run this particular DAST scanning, so it will run on later stages like on staging or pre-production environments before it goes to the production. So we simulate attacks onto the application and see how it responds. So let's see what it tests. It tests the fully running application for real world exploitable vulnerabilities, including issues with authentication, business logic, and exposed APIs. So why it matters? It catches the runtime flaws that static scans or dependency checks cannot. So whatever we did in the previous SAS scans, right? So that focus only on the application logic, application code. But here it simulates the real-time attacks on the application and see what can breach, and it generates the result. And the popular tools in DAST. So some of the popular tools are Checkmarx, JIT, Intruder, OSAP Zap, Veracode, Escape Dast. So this is how a simple Dast pipeline runs. First it scans, okay, the code, the application, then it simulates the attack, then identifies the vulnerability, then it starts reporting, and then we will fix the problem again, and then start scanning, attack simulation, vulnerability detection, and it continues. As long as the report has some observations, it will fail your application, and so that your deployment will not happen onto the production. So your application is actually being scanned before going to the production for any real-time attacks onto the application. This is a simple Checkmarx DAST report. If you see, we have 4 applications here: consumer app, elections app, media app, retail app, and each application has its own findings, and it shows also how many identified critical, high, moderate, low findings, and also at the bottom it shows you category wise findings. So the developers can go through this code on the architectures. It's important for the architects and security teams and identify this and fix the problem in the code or in the implementation or in the architecture or on the security measures they have taken already, but it still have some leeches there, right? So when there is a leak, so they can go back, fix it, and come back. Now let's see a simple SAS versus DAST. So why we are emphasizing on these two? These are the very important for any IT developer or any software engineer to know for the best practices in the industry. SAST versus DAST. So it's like a white box security testing. SAST is like a white box testing. So the tester would be actually testing against the code. So they will inspect the code and they will write the test case accordingly. Black box security testing, it's actually the developers or the testers, okay, they actually don't look at the code. Okay, the tester would focus only on the execution of the application, not on the code. SAS requires the source code, so because as we mentioned earlier, it tests against the source code, and DAST would be running testing only on the running application, and SAST would find the vulnerabilities in the early SDLC. So here, software development lifecycle we are mentioning earlier, right? So it finds the vulnerabilities early of the development phase, And whereas dast finds these vulnerabilities at the end of the SDLC but before the production deployment. And SAST is very less expensive to fix because it's very early of the SDLC. Dast is more expensive to fix because it's already, so we have to again initiate the entire life cycle of development, testing, pre-prod integration. So all these steps should be again performed to resolve those issues that were identified in Dast. And in the SaaS, it cannot discover the runtime related issues like execution level issues it cannot identify. That is Dast, SaaS, sorry. So when it comes to Dast, it will identify the runtime issues of the environment. Okay, so it is more of customer oriented. When we release this product, so what's going to happen with the security? That is what SaaS, Dast will do. Okay, and SAST will support the scanning of all types of softwares, but whereas Dast will work only for web applications and web services where they're exposed of using the web services or APIs. Okay, and that's all for the SAST versus Dast. Let's go to the next important scanning that's called software composition analysis. We call it the SCA. So when the developer is developing the code, so they depend on the dependencies. So nowadays, what's happening is the whole development is depending upon open source code. So suppose a Java developer is there and he's developing a Java application. In that, they might be using some dependencies. Say they might be using a Maven or Gradle or Node.js. So it pulls the dependency. So it's called library. So they would be pulled from Maven central repositories or Gradle repositories or from NPM repositories for Node.js, right? So when they use those components or dependencies, the dependency would be pulled into our code onto the EC2, right, through the code. So that is our EC2 means here our say for example simple words server, right, and that can cause the security breach. Okay, and also that particular dependency or library might have already been outdated and it might have already vulnerabilities, right? So this particular scenario would be discovered by SCA. Okay, so let's focus on the slide. So what is SCA here, right? When it runs, so during the build, test, pre-production, so mostly many of the projects they impose on build stage itself because they don't want to go into the later phase of the SDLC. So what it tests, scans external libraries for known vulnerabilities and license compliance risks. So if you see, I have mentioned in the CVE. Okay, so all the vulnerabilities are marked by the CVE hyphen the year number. So like for example, if the CVE was reported already using CVE in 2025, so it marks a CVE hyphen 2025 hyphen and the vulnerability has a unique number. Why it matters? Operates during build and test steps, helping teams to avoid deploying software with risky outdated components, and it is essential in today's heavy use of open source. Most apps are built with third-party components, so we will be scanning those components. So if you guys, anyone is familiar with pom.xml file, so it will have all the dependencies mentioned for a Maven based build in Java, right? So that pom.xml file would be scanned and it reports all the findings through SCA scanning. The popular tools are JFrog X-Ray, OSAP dependency check, sync, GitHub advanced security, Git SCA. Let's see how a simple CI/CD flow look like. So the developers would be doing a pull request or a commit. A pull request is like we will be developing the code in the feature branch and we'll be merging it into a develop branch or into another release branch. That's called a pull request, where earlier days the pull request used to be manually reviewed by the team lead or the tech leads. okay, for any, along with the logic, also for the issues. But through our SCA SAS tools integration, the tools can automatically scan the code and they can identify the risks. Okay, and if something goes wrong, so obviously it will report there. Okay, and then in the second step, so once that particular pull request has been successful, and the developers would be developing that particular code into build or test environment, right? So here they will be testing it for the functional testing. So basically, when the step one fails, step two doesn't happen. That's what the gate we are having there. So SAST and SAST would be running at the code level. So once the functional testing is completed in step two, so in the step three, before going at the time of staging, so DAS scans would be scanned on the application, on the deployed application. Here we have to note that deployed application means that it's a runtime already available, and the vulnerabilities are scanned for the runtime context, not on the code. And then here we'll have a dust quality gate. Okay, so when the dust quality gate fails here, so the release will not happen. That's what we mentioned in step number 4. So we'll have a quality gate. Okay, so in step number 1 we'll have a quality gate, and step number 3 we'll have another quality gate, so that we'll have very stringent policies on our application. So to summarize here, so this slide explains SAST, SCA, DAST, what they do. SAST would catch the bugs and insecure patterns in the new code before it's ever get deployed. SCA flags outdated or vulnerable dependencies on every commit or build. DAST scans staging pre-production environments for runtime flaws, validating the security of entire deployed system. Benefits of combining SAST, DAST, and SCA. So we have a layered defense. So every layer of SDLC would be covered with various tools at various surfaces and kinds of vulnerabilities. So one type of scan will work on the code, another type would happen on the dependency, another scan will happen on the runtime. So each phase will have its own layer of scanning, and automated scannings are very important. So instead of we deciding whether the scan should fail the pipeline or not, so if there is a vulnerability found, so it should fail immediately, so we can keep thresholds so that the pipeline gets broken once that particular security scan has marked as some vulnerabilities. So we can keep, say, if it finds 5 critical vulnerabilities in SAST, it just fail it. An overall report of say suppose SonarQube marks as 80% fail or 80% pass, so you should give some numbers and it will fail that pipeline then and there only and gives the report. Fast feedback loops, so developers are notified of the issues early and more frequently, and it improves the productivity and enables security coding habits. So they know the security practices already, and they get used to those habits of implementation, good security practices. End-to-end risk reduction. So custom code, dependencies, and running applications are secured throughout the pipeline, not just at one point. So we have quality gates everywhere. And there are a few more scannings which are good to implement in your security pipelines. That is secret scanning. So this is very much happening in recent days because the developers might be pushing the code of secrets. Okay, so they want to test something on, for example, they want to keep password, username and password to a database to make their testing simple, right? So because they might be in early stages of the development, but still they want to do a database connectivity. Okay, so they want to test it in a simple and faster way, and they might have used username and password in the code to connect to the database, so which is breach, right? So the security scanning would scan the source code, configuration files, and other artifacts to identify any hard-coded API keys, passwords, tokens, and other sensitive credentials like keeping the private keys or AWS username and passwords, AWS keys, anything okay that is breaching the security, it will be identifying. When it runs, integrates early in the CI/CD pipeline during the code commit or pull request. The key benefit here is it prevents accidental exposure of sensitive information that could lead to data breaches. Popular tools, Git Guardian, Trufflehawk, Gitlix. Okay, here I will explain one scenario. So you might be working on AWS development and it needs AWS keys, security key and secret key. And so when someone uses GitHub public repository and unfortunately if they push that particular keys onto GitHub public repository, immediately the hackers, they will catch that those keys and they'll start spinning up AWS resources like S3, EC2, which are going to incur thousands of dollars for you within a few minutes. Okay, so you will be notified that breach from AWS, obviously, but at a corporate or organization level, it is going to be a reputation issue and also the cost, right? So you might have seen like there might be a lot of programs that are coming through the organizations like bounty programs. So whenever someone identifies that there is an issue, the organizations are giving them like a token of appreciation through bounty programs. So we can participate there also, and to so that we can do the scannings on the applications. So the secret scanning is very important for any organization. So this slide shows, maybe slide is a bit smaller in the size of the pictures. So on the left hand side, I'm pointing my mouse here. So it marked critical. Two observations are being done here. And here in this right side top, I will explain here the one of the identification of that vulnerability. Okay, so the tool used here is Gitlix, and scan type is secret detection and severity is critical, and it gives me the path and the file where it identified, and it identified okay the entire the secret here. Okay, so that there is a leak here, someone pushed the code with secrets. And GitLab, so here I'm focusing on GitLab here. Okay, it's a CI/CD tool like Jenkins. It is as simple as implementation would be like if you want to have GitLab to scan by its own framework. So on the line number 3 here, you can see the template secret detection. So when you include this particular template, okay, GitLab would be scanning this particular your code using Gitlix. That is the default scanning provider for GitLab. So if you want, you can do customization with your own secret scanners as well. And next one is the container scanning. So in the world of containers, so you like Docker, Kubernetes coming into the picture. So it is very important we scan those images as well, Docker images. So it analyzes container images and their layers, including the operating system, libraries, and application code. And what it detects, identifies known vulnerabilities in OS packages, application dependencies, misconfigurations, and compliance issues within the container. When it runs, integrated early into the pipeline, so typically during the image build, as I mentioned, so it's a Docker image when you're building. Okay, so it's also like a simple building of a standalone application, but here we make it as a image that would be deployed into any Kubernetes runtime containers. Okay. Also, before we build, after we build, but before we push that into the container registry, so we can do this scanning as well. So we have two layers of defense here. So the key benefits of this container scanning is it ensures that only secure, compliant container images are deployed to production environments, reducing the attack surface. The popular tools for container scanning are Trivy, Sync Container, Aqua Security, Anchor, and Clay. And so here a simple scan report here. It just shows the scanning on the Docker image. That it's a report from the Clay. It says it has reported a lot of CVs. So as I mentioned before, so if you see the CV hyphen the year number and the unique CV number here, so you can go and find out the vulnerabilities and the remediations, and we can go and fix it and come for the scanning again. So here I gave the template example in GitLab. That if you see the by default, so templates are provided by GitLab. So default security scanning is provided by GitLab. So if you include this one and mention the image, what image you want to scan, it does the magic. And before we go to the conclusion, so the best practices we discussed already. So automate the security scans everywhere, and so we can define the flow through the automation and fall. Let's fall first and then inform early. Like it means let's fail and fall early so that we can fix it early. Centralized findings, so we can put it as a dashboard so that it is visible and transparent to everyone, and identify the issues and triage them at the earliest. And implement it as a policy as a code. That means the pipelines are to be implemented such a way that so every project would be automatically updated with that policy, so that no one can manually override it or no one can escape the policy to escape the scans. So this is very important for organizational security compliance. Secrets management, so never store credentials in the code. Use secrets into the vaults or secure configuration tools. Continuous monitoring, so integrates runtime monitoring for the new threats and correlate with early scan data. So always continuous monitoring analysis is important for us. So what is the advantage of using this particular DevSecOps tools into the pipeline? So we can release our applications 30% faster than using the regular traditional way of security implementations in the olden days, and reduce risk for up to 60%, and the costs are 100% savings, because we are going to fix these threats at the earliest stages of the SDLC lifecycle in the projects. And coming to the conclusion, embedding SAST, DAST, and SCA into every stage of the pipeline transforms security from an afterthought into seamless automated guardrail. DevSecOps is now a competitive differentiator, empowering teams to deliver software that's not just fast, but resilient and trusted. That's all from my side. Thank you for giving me opportunity. Any questions?
Thank you, Mr. Naga Murali Krishna Koneru, for your highly informative session. Your presentation on integrating security into CI/CD pipelines through DevSecOps with SAST, DAST, and SCA offered valuable insights into embedding security seamlessly into modern software development. We truly appreciate your contribution to ICCCNet 2025.